Okay, so here's the next instalment, and we've introduced the idea of the factor theorem and remainder theorem. We haven't gone into a lot of depth. I've left up this little guy that we're going to continue to work with throughout, but for this video I want to carry on formalising this process. So when we've applied the factor theorem, we've got a polynomial, which is p of x. Okay, now this is what it's going to look formally like. The polynomial p of x can be written as, if it can be factorised, it can be written as d of x times by q of x. Now, that's going to seem a bit weird, but let me explain what these guys are. So p of x is the original polynomial for this structure, and p is just there because it stands for polynomial. That's the reason why we go with that. D of x is the thing we're dividing by. It's the factor. In this case, the example we're dealing with, we worked out the linear factor, x minus 1. That's our d of x. Q of x is the bit that's left over as part of the multiple. And if we divide everything by d of x and restructure this, q becomes what's called the quotient. That's why it's called q of x usually. So we get that. If it's fully factorised, it's that. But there are times, sometimes, where we might actually kick in with the remainder theorem, which we'll go through in a later video. Now, you might also see this. If you're looking at your textbook, you'll see a little r of x as well. And this could be a capital R, that could be a capital D in some cases. That doesn't really matter. But that's our remainder. So if you divide a polynomial by some divisor, x minus 1 or whatever it is, you end up with what that needs to be multiplied by to get back to the cubic, but you might have a little bit left over. Okay? It's a little bit like when we do it with numbers. So for example, if I did, say, 71 divided by 10, well, I can write down 71 is equal to 10, my divisor, times 7, but I've got a 1 remainder. So I've got to deal with the fact that I've got a 1 remainder. So it's a bit like that for number, but this is for algebra. So that's the structure. That's the big picture structure. But what I'm going to talk about now is not really the remainder. I'm going to talk about this in this sense and how we could factorise that. So you remember in our last video we had p of x was equal to x cubed plus x squared minus 9x plus 7. And we said that this was equal to x minus 1 times by something. Okay, and so I've done a bit of a double equals on one line. Okay, I shouldn't do that, but let's just ignore that's there. So I'm saying, oh, I did the factor theorem, I put 1 into here, it was equal to 0, so this is a factor, and I'm left with something else. So that can be factorised by x minus 1. Now, here's one method, and it's a method I prefer, but it's really up to you. And I'm going to do it using the long way, but you can be quite logical about it as well. So I've got a cubic, and it's equal to a linear times by, think about what this is. So this is highest power 3, highest power 1, that means this has to have a highest power 2. So it's some sort of quadratic. So I'm going to write this quadratic generally. Ax squared plus bx plus c. A, b and c are coefficients. So I've got x minus 1 times ax squared plus bx plus c. I just don't know what a, b and c are. I want to work that out. What should a, b and c be so that I come back with this? Now I'm going to avoid the logic for now, but have a think about it as I'm going through it. Like for example, I'll give you the one case. What does a need to be to make those two multiply to give the x cubed? That's the only way I can get x cubed is if I've got the x times the x squared. Obviously a has to be 1. X times 1x squared is going to give me 1x cubed. So you can work it out pretty quickly. But anyway, we're going to do the expansion. And we're going to do this using the distributive property, which is x times ax squared plus bx plus c minus 1 times ax squared plus bx plus c, and that's equal to ax cubed plus bx squared plus cx minus ax squared minus bx minus c, and then I'm going to bring together my like terms. So I've got an ax cubed, and then I've got a plus b minus a x squared, that's this one and this one. Then I've got a plus c minus b x, and I've got a minus c. Now what we're going to do is a little bit of, a little pink pen here, what is called equating coefficients. So over here I'm going to just put it down, x cubed plus x squared minus 9x plus 7. So we'll start with pink. I've got a 1 here and I've got an a there. 1 equals a. Has to be true. It's the only way this can work is if a is 1. So there's my first one. Okay, now I've got my yellow pen, and we'll do it again. This time I might sneak down to here. 7 and minus c. So I've got 7 is equal to negative c, which leads to c equals negative 7. So I've got two of them. I've got A and C so far. And the first and last are usually the easiest to deal with. We'll change colour again to green. And we'll go with the x squareds. So I've got a 1 there, and I've got b minus a here. So I get 1 is equal to b minus a. And I know my a is 1 already, so I get 1 is equal to b minus 1. And I get b is equal to 2. Now I've got 4 pieces of information here, but only 3 unknowns to find. So I've got this little, let's call it a parity chip here. I can just make sure it's okay. Negative 9 should be c minus b. So it should be negative 7 minus 2, and that is negative 9. So we're good. We've got a good answer here. So that means that A is 1, C is negative 7, B is 2, and because I don't want to go down too much lower here, that means that I should get x minus 1 times by my quadratic x squared. B was plus 2x, and then C was minus 7, x squared plus 2x minus 7, which if you have a look at the top here is what we started with. So that's one way of factorising by equating coefficients. But just before we finish the video, I would like to draw your attention to, again, this concept we're talking about of being able to just, not cheat, but just make some little tricky observations. Because ax squared and x are the only way to get this x cubed, so I can see a has to be 1. If this was a 3, well then a would have to be 3. I can see that. So I can write down what a is straight away. And see this plus 7? The only way I'm going to get a plus 7 is minus 1 times c. C has to be negative 7. It's the only way to make that work, so I can work out c. And then I could set something up for finding b like this. So you don't necessarily have to do this full expansion, but you know what? It's a great place to start to just make sure you're getting things right. Good luck.